So in this recording we're going to look at the Bitwise OR, and I'm going to take two numbers. I'm going to take x, y and z, similar to what I did in the Bitwise AND program, and I'm going to put some numbers to these. So I'm going to put the x to be a 3 and the y to be a 15. Okay. Now these are all integers, so what I'm going to do is I'm going to say z is assigned x or y. Now, looking at the binary numbers for these, 3 will be 0, 0, 0, 0, 0, 0, 1, 1. 15 would be 0, 0, 0, 0, 1, 1, 1, 1. When we OR these, 1 or 1 will give us a 1, 1 or 1 will give us a 1, 1 or 0, what does that give us? Well, if we look back here to the truth tables for the OR, we can see 1 or 0 will give us a 1 as well, so that's perfectly fine in this case. Gone too far. So that's a 1, and the same for this, a 1. However, 2 zeros will not give you a 1 out, so we get all zeros in this case. So as we see, the answer to this is 4 ones. All the zeros here are obviously going to be 0. 4 ones together. Happen to know that that's 15, but you can check it on the table back here. So we can see that that's 15, or an F if you want to write it in hexadecimal. So it's going to be an F there, or a 15. Okay. So let's have a look and see if we can run that program. So what I've done is I've taken the Bitwise AND and I'm just going to modify it. So I'm going to say x is the value of 3, y is value of 15. Rather than 15, I'm going to put it in as its hexadecimal value, which is just a single F. I'm going to OR the two together, which is using the symbol that's down between the shift key and the Z key. And then I'm going to print it out. I'm going to get rid of these. They're not useful to me at the moment. So we just run that, and we can see that the result that's come out is 15. Okay. If I want to see that in hex, I can say %x, and you can see that Z has come out. Z is F, and if I want to see that as a capital F, I just use a capital X here. Okay, there we have it. So Z is F. So that's the Bitwise OR, and then you can use that for any manipulation in which you need to use an OR for. Okay. Now, this can be quite useful if you recall in the previous one where we looked at the AND, if we wanted to find out if a single bit was a value of 1 or 0, we could AND with a number that had a 1 in that position. What we can do with the OR is we can ensure that anything that has a 1 in our second number becomes a 1 in the next one. So let's take an example. If I have a number like we have up above, 0, 0, 0, 0, 0, 0, 1, 1, and I want to ensure that these two bits here are changed to 1s. Okay, what I can do is I can OR it with the following numbers: 0, 0, 1, 1, 0, 0, 0, 0. And all I'm doing here is I'm physically making sure that these two get changed to 1, but I don't want to change anything else. Okay, so I don't want to affect whatever the situation is here, 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 and here. So if these are zeros, I want them to continue to be zeros. If they're a 1, I want them to continue to 1, but I just want to set these two. Again, that's useful in an embedded system where we want to set some parameter within a register. We want to switch something on, and we can do it by this mechanism. So when we OR these two together, we'll get 0, 0, 1, 1, 0, 0, 1, 1. Just to prove that, I'll take this number here and put it in its two sections, which is going to be 3 and 0, and that's if it's given in hex. So let's try that, and this number here we can see is clearly going to be 3, 3, and that's again in hex. So let's have a look at that. So if this number here is going to be 3, 0, so we're going to OR with that, OR the two together, and let's print out the result. And we see that the result that's come out is 3, 3. Okay, and that's in hex. So I should probably write 0x in front of this, just to clear on what's actually coming out there is coming out in hex. So there we see our answers there, 0x33. So again, something that you'll be using throughout embedded systems and embedded programming is the Bitwise OR.